Hello, hello. Welcome, Course 3 students, to our 5th lesson here in Chapter 4. So all we've done so far has been focused on exponents as well as scientific notation. So moving forward here, or at least the next 2 lessons, we're going to be focusing on talking about square roots or squares. So squares are when we take any number to a power of 2. So a lot of times you'd hear me say like 2 squared, 4 squared. So they're kind of showing that on this side of this picture here. 5 squared, meaning, 5 times 5. So that is my square, but if I want to do a square root, basically it's the reverse order of squaring something. So instead of given the actual amount or the actual number it would be, once you solve it out, I'm going to undo that square. So I want to think what times what will give me 25? Well, 5 times 5 gives me 25. So we're going to be taking a look at squares and square roots today. So your objective is I can learn to find square roots. So we have a lot of different kind of words here within here. So this is the first part of our textbook. Here's what it says, and I'm going to break it down a little bit more as we go through. It says, think about the relationships between the area of a square and the length of one of its sides. So if we're talking about a square, right? Here's a square, as best as I could draw. It looks more like a rectangle. So for instance, maybe they say the area is 36 square units. Well, if we have a side length of 6, remember if it's a square, that means that all the side lengths are going to be the same. And remember, when we solve for a square, we take the length times the width, or we multiply 2 of the sides. And so we're taking 6 squared, which gives me 36. So it says a number that, when multiplied by itself, to form a product is the square root. So I was talking about that. So 5 squared, 6 squared. So it's just multiplying it by itself of the product. Taking the square root of a non-negative number is the inverse of squaring the number. So like I said, squaring something and then taking that square root is going to be the opposite of it. So if I take 6 squared, which equals 36, but if I want to take the square root of 36, I go backwards and I think what number times itself would give me 36, and that number is 6. Every positive number has 2 roots, one positive and one negative. We use this symbol, and it's a little hard to see in there when they're writing. But it is called the radical symbol, which indicates the non-negative or principal square root. The negative square root then uses to indicate the negative square root. So they're saying there's a negative version and a positive version, because think about this. If I went back and I thought about the square root of 36, well, 6 times 6 would give me 36. But wouldn't negative 6 times negative 6 also give me 36? Remember, a negative times a negative equals a positive, so it does also give me a positive 36. And that's what they show down here as well. They just show that if you use the square root, typically we're looking for that positive version, but if you do keep that negative on the outside, we're going to make it that negative 4. Because this one's the square root of 16. You can use the plus or minus symbol as here to indicate both square roots. So sometimes you'll see in this case they say the plus or minus, meaning the positive version and the negative version of this number. So if I wanted to say, the positive and negative version of 6, I can write plus negative right next to 6 instead of writing 6, comma, negative 6. Saves me a little bit of time. It's just another way that we can express that here in math. It says the numbers 16, 36, and 49 are examples of perfect squares. A perfect square is a number that has an integer as its square root. Other perfect squares include 1, 4, 9, 25, 64, and 81. So today we're going to be working with pretty much perfect squares. And we're going to be talking about things that when I take the square root, I'm going to get one answer or one number. Tomorrow, we are actually going to take a look at when we take square roots, and they're not going to be perfect. I'm going to have a decimal version of that as my solution. And we'll be working on kind of figuring out those. So today, for the most part, we're going to have nice, easy numbers to be working with because we're going to be working on perfect squares. So let's take a look at this first example. They say to find the two square roots of each number because remember, I can have the positive and the negative version of that solution. So let's take a look at that first one. A lot of times then when we rewrite the square root, we take it and we write it like this, and then we put the 81 below it. So I want to think what number times itself gives me 81. Well, I know off the bat, using my math brain and using my understanding of multiplication, that 9 times 9 gives me 81. So if I was to undo this, it would be 9. Now they want the positive and the negative, so I would actually write this as this positive negative 9. You could also write it as 9 and come negative 9, whichever one works better for you. But they want that positive and that negative version. B, I have the square root of 1. Now remember, they said to find the square root. They just didn't put that symbol in. Well, what number times itself, one more time, would be 1? Well, 1 times 1 is 1. So in this case, the square root of 1 is 1. And again, I want to have the positive and the negative, so I'd write it as positive negative 1. Or again, you can write it as 1 negative 1. All right, so simple right now because they are clear, direct answers. I'm not having weird decimals. I'm just thinking what number times itself is going to give me this number that I originally started with. So now I have the square root of 144. Well, I know 10 times 10 is 100. So it's going to be more than 10 times 10. What about... I know that 11 times 11, I think, is 121. So 12 times 12. And remember, you can always double check. You could write it out and think, okay, 12 times 12, do the math. Do you get 144? You should end up getting 144. So my answer for this one is 12, but I need the positive and the negative version. So, or I could write it as 12, negative 12. All right. So that is my solutions for the first one. Now, like I said, it did give me the direction to give the two square roots, so the two different versions. If they do not direct that, you are only going to give me the positive version. So as we kind of move forward here, my biggest answer is probably going to be that positive version of this number. Okay? So let's keep moving forward. We'll take a look at the next answer. Or sorry, next problem. So this one though, example 2, I kind of like this one because it's a little bit more of a relatable problem, I guess. So it says the square computer icon contains 676 pixels. How many pixels tall is the icon? Write and solve an equation to find the length of a side. So they're saying on your computer, you've got a little pixel square that shows this N here. I don't know what app this is for, but they're using 676 pixels. Remember, pixels are little dots that make up kind of this shape within here. And it is in a square shape. So if you remember, when we were talking about squares earlier in this part, squares are, you just multiply them by their sides, but also that means that I'm going to take this side times this side, and that would be showing me side squared. So what they're saying is if I took these two sides and I square them, I'm going to get 676. Oh. All right. So what they want me to do is write and solve an equation to find the length of one side. Well, guess what? I already basically came up with an equation by explaining this a little bit more to you. So what I'm saying is the side squared equals 676. I need to solve it for the side. And so we had talked about squares, and one thing also to talk about with square roots then is that square roots undo squares. So if I'm going to take s squared and I'm going to square it, what happens is the square and the square root cancel, and I'm just left with s. But remember our rule, whatever I do to one side, I have to do to the other. So I'm going to also have to square root 676. Ooh, that's a big number. Off the bat, I'm going to use what I know. I personally know that 25 squared is 625. So I would think 26 works, but if I'm not 100% sure, I can still multiply them and see, does it give me that number? I am going to use my funky way of multiplying, the lattice method. But you can use whatever method that you enjoy multiplying with. And then I'm just going to add them up. That doesn't seem right. I didn't do this right. 12. There we go. I was like, that doesn't seem right. Alright, so yep, I would have 26 would work because I did get this 676 because 26 times 6. So my s squared would be 26. So that means each side would be 26 pixels. Oops, I didn't spell pixels right. I don't even know if I typed it right. Who knows how to spell pixels? I don't think I spelled it right. No, it's ELs. Okay. I think we have one more example to get through. So let's take a look at these ones. It says, in the order of operations, everything under square root symbol is treated as if it was in parentheses. So anything under a square root is an operation that I need to do before I can do something else. So it's a lot like a parentheses or part of that parentheses operation. So we are going to simplify each expression, and they talked about your order of operations, so we are also going to use the order of operations. So they said that square roots are similar to parentheses, and so we're going to do them in the same step as parentheses here. Okay, so I would say square roots here. I'm just going to abbreviate square SR. So I got to take then the square root of 25. Well, what number times itself is going to give me 25? And a lot of this just comes down to knowing my basic multiplication. I know that 5 times 5 gives me 25. So now I would have 3 times, because remember right next to each other showing me multiplication, 3 times 5. And that gets rid of that square root, plus 4. Well, we don't have any exponents. We do have multiplication, so let's do that first. 3 times 5 is 15, plus 4, and that's my last operation, so I would get an answer of 19. All right. And then B, this one should be 16 out of 4, like more as a fraction, but remember, this also shows me 16 divided by 4. So they talked about the parentheses. I need to do that first. So 16 divided by 4 is 4, but that still means I have this square root of 4. So from there, then, I have to still take what is the square root of 4. I can't just say, oh, well, the answer is 4. I have to do the operation in the inside first, then take the square root. Square root of 4 is 2, so then 2 plus 1/2 equals 2 1/2, and you can leave it as that. So we will keep working on this here in class. Let me know if you've got any questions.